NASA has been launching missions for decades, but they're just scratching the surface when it comes to the mysteries of space. So, I'm throwing some cosmic anomalies out there for you, just to see what you can make of them. I'll provide the info, and all you need to do is sit there feeling puzzled. Our team went on a long and arduous mission to assemble these facts, so don't let them down. I'm Mike with List 25, and these are 25 space anomalies that even NASA can't explain. 25. Tabby Star. Stars shine brightly in the sky, and then die out, getting fainter and fainter before switching off like a light bulb. Or do they? The case of star KIC 8462852, also known as Tabby Star, after the astronomer who reported it, challenges what we think we know about the cosmos. For some reason, its light is diminishing, like someone's playing with a cosmic dimmer switch. Fluctuating starlight isn't unusual, but Tabby Star behaves in ways that experts haven't seen before. Readings show an enormous 20% drop in brightness before things go back to normal. Why is the light so unpredictable? There are explanations, such as space debris passing in front of the star. However, these are far from confirmed, leading to conspiracy theories. Could the light from Tabby Star be getting interrupted by a vast alien structure of some kind? Keep watching the skies. 24. The Fermi Bubbles. Did you know there are two huge balloons in the middle of the Milky Way? The Fermi Bubbles aren't just long, they're 25,000 light years each in length, extending above and below the center of our galaxy. The name comes from the telescope that spotted it in 2010, the Fermi Gamma Ray Space Telescope, which is currently in orbit around the Earth. The balloon-like bubbles produce gamma radiation, or high-energy X-rays. Appearance-wise, they've been described as lobes with sharp edges. So, what are the bubbles? To answer that question, you need to stare into the heart of the Milky Way, where a supermassive black hole named Sagittarius A lives. Some experts think Sagittarius A sucked in atomic gas, which then produced the two bubbles. Or they might have been created during the formation of stars through intense releases of cosmic energy. Either way, the universe is indeed blowing bubbles. We're just still trying to figure out who's doing the blowing. 23. The Great Attractor. We know it's powerful, we just can't get a decent look at it. The Great Attractor, a major gravitational force, was first speculated upon in the 70s before being located in the 80s. Frustratingly, the attractor is largely invisible and lurks behind a curtain of dust and gas dubbed the Zone of Avoidance, which is a shame because this epic space anomaly has a hold on us, pulling us and thousands of other galaxies toward a part of cosmos called Hydra Centaurus. That's a supercluster or a collection of materials that is drawn together, a lot like the Great Attractor is drawing the Milky Way in right now. We're apparently heading for the center of Hydra Centaurus, where we'll join the rest of the intergalactic jumble. Actually, we probably won't, since the universe expands as much as it contracts, so we may not reach it in the first place. 22. Dark Flow. There are various forces in space that influence how objects move, from meteorites to whole galaxies. One of the most mysterious is dark flow, which is a theoretical idea, but also highly compelling. It explains why hundreds of galaxy clusters appear to be moving in the same direction at a surprising speed. The flow was partially spotted when measuring something called the cosmic microwave background, a heat source believed to have been left behind following the Big Bang. Dark flow doesn't match up with previous ideas about the pull of gravity, plus the old idea of our universe expanding and moving things along that way. So, what causes it? It's probably something we're not aware of yet, still waiting to reveal itself and blow our minds. 21. Cosmic Void in Boötes. Space is a living thing that's always moving around, placing stuff here and there. It's constantly arranging and rearranging the stars, planets, and chunks of rock that form our universe. Like with any big project, there's bound to be the odd gap left behind, but nothing like this. The cosmic void in Boötes is thought to measure around 330 million light years across. It features so little in it that it got the alternate name, the Great Nothing. How empty is the Great Nothing? There are definitely some galaxies and other things in there somewhere, but they exist at a surprisingly low density. This makes it one intriguing void for astro experts, who've added it to their list of baffling space phenomena. Boop boo ba doo doo. Phenomena. Boop boo doo boo. 20. Hanny's Voorwerp. Hanny's Voorwerp gets its name from the teacher who found it in 2007, Hanny van Arkel, and the Dutch word for thing or object. Basically, this cosmic anomaly is Hanny's thing, and that's not even the strangest thing about it. The Voorwerp is a glowing sea-green cloud of gas located 650 million light-years away that was a head-scratcher for scientists. Why? Because it was shining without any stars inside it. They didn't know where the light was coming from. In fact, it took them approximately 3 years to figure out that the glow was actually from ionization, a process where the gas atoms get zapped with energy powered by a distant quasar. Quasars are the brightest, most powerful objects in the universe, typically found at the core of galaxies. What's truly bizarre is that the quasar that created this light show has already shut down, and what we're seeing now is just a light echo from a powerful beam that fired 100,000 years ago. 19. Hoag's object. This ring galaxy looks so perfect it could almost have been made by an artist. Believe it or not, it was created naturally. Only scientists haven't worked out how yet. Hoag's object, named after astronomer Arthur Hoag, has been known about since the mid-20th century. The ring shape was formed from a mixture of old red stars on the inside and younger blue ones on the outside. Unfortunately, though, we can't investigate it too closely due to its being 600 million light-years away. Did the ring separate from the core after a collision with something? Or could it have come together in a completely random way? Hoag's object is a head-scratcher, even for people who seem to know everything. 18. Repeating FRBs. FRB stands for Fast Radio Burst, a radio wave pulse from space that's picked up by astronomers here on Earth. Usually these happen once, but sometimes they repeat, and the reason they do this is a big mystery. Before the discovery of the first repeating FRB in 2012, people assumed they were caused by something like an interstellar explosion. The fact that the burst happened again and again showed there was probably another explanation. Highly magnetized stars called magnetars may be responsible for the radio bursts, though research is ongoing. 17. The Dipole Repeller. Here's a weird fact about space. There are deep pockets without much in them, which nonetheless put pressure on our galaxy. They don't have much density, yet they're still powerful enough to shift us around. One such pocket is the Dipole Repeller. This is located on the opposite side of the intriguingly named Shapley Attractor, another source of motion in our galaxy. Technically, the Dipole Repeller doesn't repel us. It simply doesn't produce enough gravity to do that. Instead, it creates the impression of repelling us, whereas in fact, we're moving away from it in the absence of any powerful gravitational force. Scientists believe that the speed of our galaxy, some 600 kilometers per second, is partly due to the Dipole Repeller. 16. Galactic Rotation Problem. Stars rotate at the center of our galaxy, and they do so rapidly. There are also stars on the outer reaches of the galaxy, which shouldn't be moving as fast. After all, the center is where the action happens, so theoretically things start to slow down once we get to the outer regions. However, scientists were surprised to discover the stars are as fast outside as they are inside. Why is this significant? Because according to established thinking, there isn't enough gravitational pull to stop these outer stars from spilling out in all directions. Think of it like someone made a hole in a bag of marbles. So if the marbles aren't spilling out, what's keeping them in place? They believe dark matter may take the strain here. Dark matter is a substantial galactic force, but it's also invisible, and the theory hasn't been definitively proven yet. That begs the question, if it isn't dark matter keeping those stars moving, then what is it? 15. Milky Way Warp. We have a lot to be proud of in our galaxy. It's been around for billions of years and should be alright for another few billion. That said, it's showing signs of wear and tear. For example, there's the Milky Way Warp, a distortion in the shape of the galaxy. The Milky Way is a spiral galaxy shaped like a disk, though with the warping it forms more of an S shape. What made us this way? Dark matter plays a possible role, though experts like the idea that a big collision in space somewhere is sending shockwaves through the disk and bending it. 14. Galactic Cannibalism. The Milky Way is big enough for all of us, but there's a strange fact about it you probably don't know. It's big because it eats other galaxies. Now, I'm not saying the Milky Way is roaming around the cosmos just gobbling down galactic nuggets like a monster in a horror movie. Galaxy consumption happens through gravity. When one galaxy meets another and gets absorbed, the polite term for that process is a merger. A less polite one is cannibalism. Plus, we can witness it going on right now, as astronomers watch a dwarf galaxy called Sagittarius breaking apart and wrapping what's left around our solar system. Let's just hope one of these galaxies don't give us indigestion, eh? 13. The Flyby Anomaly. A spacecraft uses the gravity of a planet to change its speed relative to the sun during a flyby. This makes it either slow down or speed up, a cool move known as a gravity assist. You may also be familiar with the name slingshot maneuver, which applies when the spacecraft is sped up. Actually, speed in general is a curious thing when it comes to flybys. Scientists have noticed a small increase in speed during Earth flybys, measuring several millimeters per second, which weren't part of the original flight plan. These increases aren't enough to be very noticeable, but even so, the anomaly is there. So what causes it? The flyby anomaly is possibly caused by things like the angle you approach the planet at, though ultimately the experts at NASA aren't sure. That's why it's on this list. 12. Interstellar dust enrichment. Chemistry can be a complex subject. There's actually a thing called complex chemistry, relating to things like polycyclic aromatic hydrocarbons or amino acid precursors. I don't expect you to know exactly what those things are. I mean, I can't say that I'm clued up on the topic myself. All you need to know is there are organic molecules that exist both here and deep in space. The thing is, when did these molecules first appear in the universe? We thought they appeared after the Big Bang. Initially, scientists saw the earlier days of the universe as lacking in heavy elements, meaning the heavier stuff probably came later. The molecules I just talked about wouldn't have had the right environment to develop through a process called interstellar dust enrichment. Experts had to change their opinion on this as telescopes and other equipment became more sophisticated. When they noticed evidence of heavy elements in material going back to the younger days of the universe, they saw interstellar dust enrichment in a whole new light. What created these elements relatively soon after the Big Bang shot its bolt? We still don't know. 11. Blue straggler stars. Straggler is kind of an old school word, so if you're confused, let me explain real quick. It means when someone or something is slow and left behind by a group as a result. When I mention blue straggler stars, I'm talking about clusters of stars which feature separate stars that are noticeably younger. They're stragglers in the sense that they're aging more slowly than all the other stars. Or at least that's how it seems. The truth is, they're the same as the other stars. They're just interacting differently inside the cluster. When stars knock into each other, or their fields of gravity cross over, it gives them a boost, making them look younger, bigger, and brighter. Energy can also be transferred between stars, producing the same kind of effect. Who knew there was so much going on in the world of stars? 10. Zombie stars. When a star explodes, the effect is called a supernova. There's no coming back from a supernova, right? Wrong. There are freaky yet fascinating anomalies that return from the dead like a zombie within sniffing range of a fresh young brain. In fact, this type of star is a white dwarf, as in the core of a sun that's exhausted its fuel supply and gone to pieces. The white dwarf itself then dies. However, that doesn't happen in the case of a zombie star. It's an anomaly caused by a minor explosion that doesn't have the power needed to wipe out the dwarf. Failing to reach this critical mass means it definitely goes bang, but the bang isn't big enough, leaving a zombie of the star behind. 9. Unexplained X-ray emission. In order to have X-rays, you need radiation. This makes the so-called X-particle line a true space anomaly. It's an X-ray signal from deep space that seems to emanate from areas with no atomic content. The signal is in the Milky Way, and has also been detected in neighboring systems like the Andromeda Galaxy. We've been aware of this unexplained X-ray emission since 2014, though pinpointing the cause is a whole other matter. It could be that the signal is evidence of dark matter particles decaying. That's exciting for space buffs, as dark matter is something that's often talked about, but its existence hasn't been proven. Of course, it could also be issues with the astronomer's equipment or other factors that might lead experts down a blind alley. 8. CMB Anomalies. Did you know there's something in space called the axis of evil? Don't worry, it isn't a race of hostile aliens planning to invade us. This axis is a line found in the CMB, or cosmic microwave background. It's made up of unusual fluctuations in temperature, which shouldn't be all lined up together in a neat little sequence. The axis isn't evil as such. People call it that because it contradicts how the universe is supposed to behave. Astronomers have been surprised to see this type of anomaly in the CMB, but the axis of evil isn't the only thing that has them scratching their noggins. There's a phenomenon where one half of the sky has different fluctuations from the other, seemingly divided down the middle. What causes that? Maybe there are aliens up there messing with stuff after all. 7. Dragonfly 44. Don't be fooled by the pretty name. This awesome anomaly is one of the darkest in the universe. By dark, I literally mean dark. Dragonfly 44 is the name given to a galaxy that's believed to be composed of dark matter. It has a similar mass to the Milky Way, but not many stars. Because stars are thought to be a key ingredient of a solar system, the presence of Dragonfly 44 has confused experts. At 326.2 million light-years away, we're not going to be exploring it anytime soon. All we can do for now is gaze at it through a telescope, hoping someone or something will switch a light on. 6. The Pioneer Anomaly. Space missions are carefully planned, with NASA scientists leaving nothing to chance. Of course, once those ships and satellites are out there, unpredictable things can happen. This was the case with Pioneer 10 and Pioneer 11, two robotic spacecraft that blasted off in the 70s. The idea with these two probes was to investigate the solar system beyond Mars, though after a few years, Mission Control noticed something strange. The Pioneers had not only accelerated, but were heading for the sun. Number crunchers among you may be interested to know that the speed had increased by 8.7 times 10 to the negative 10th meters per second squared. In other words, it was pretty fast. So why were the probes floating in the direction of that big yellow ball? Experts couldn't rightly say. However, that by doing this, the Pioneers were showing a whole new approach to gravity. All the calculations in the world couldn't have predicted this anomaly in deep space. 5. Unruh Effect. Our next anomaly dates to the 70s, and is more mysterious than most. Why? Because no one's managed to prove it yet. The word Unruh itself means restless, and the theory relates to temperature in space. We see it as a cold vacuum, but what happens if you accelerate through this vacuum? The Unruh effect dictates you'd start to feel hotter. How come? Theoretically, you'd be experiencing a thermal bath through a reaction of particles. This is connected to quantum field theory and is a little too complicated to explain here. The main takeaway is that if you feel chilly in space, the best thing to do is speed up. I should point out that at this stage I am not an astrophysicist. I'm just a fun guy who likes facts. 4. Quantum vacuum energy. A vacuum in space doesn't behave as it should. That's what scientists have speculated thanks to the theory of quantum vacuum energy. This says a space vacuum is more than simply a gap with nothing in it. Look at it through the prism of quantum mechanics, and you may find that it has its own energy, complete with particles, fluctuations, and density. We've shown there's definitely something going on in vacuums, through a discovery called the Casimir effect. Named after Hendrik Casimir, a Dutch physicist, it featured a couple of metal plates, placed close together in a vacuum environment. These plates were observed to be slightly attracted to each other, revealing the presence of a form of energy. Whether this is actual quantum vacuum energy or not is a question hanging in the air. Or should that be the atmosphere. 3. Impossible cosmic rays. How powerful are cosmic rays? According to the laws of physics, they get weaker the closer they get to Earth, which makes this next story totally baffling. Rays exceeding the Greisen-Zatzepin-Kuzmin, or GZK, which stops at 5 times 10 to the 19th electron volts, have found their way to our planet. This discovery was so amazing that they even named one of the findings the "Oh my God" particle, spotted in 1991. Typically, cosmic ray protons meet the CMB, where they mix with photons. This produces pions, subatomic particles, which lead to the rays losing strength. Why are the so-called impossible cosmic rays not doing that? The rays could come from a different place with whole new cosmic laws we're not aware of yet. 2. Neutrino mass mystery. There are many different particle types in the universe, like photons and neutrinos. Those two were previously thought to be very similar in that they didn't have mass. However, in the run-up to the year 2000, it looked like that assumption was wrong. Experts looking at neutrino oscillations concluded they were changing due to mass. Now, when I say mass, I'm talking about a teeny tiny amount. That said, it's a small detail that's super noticeable to boffins who thought they understood how the universe worked. Theories about the existence of neutrinos started in the 30s, and it took 3 decades for the theory to be proved. Fast forward 100 years or so, and we still don't know why they have mass. It's one of many mysteries that may never be solved, even by the galaxy brains at NASA. 1. Black hole echoes. Black holes may be more exciting than we think. They're certainly impressive, but exciting isn't a word that springs to mind when thinking about them. As Albert Einstein himself suggested, black holes were probably lacking in features. If it wasn't for the fact that you can get trapped in them, they might even be described as boring. So it blew people's minds to hear black holes might have crazy things happening at their event horizon. These things include echoes, or signals, which are produced during the merging of a pair of black holes. Experts weren't expecting to detect much coming from this phenomenon. However, in 2012, news emerged that pulses had been spotted. Furthermore, this could show the presence of gravity waves, contradicting the idea of a smooth, bland surface on the black hole. I guess the only way to know for sure what's happening is to check out a black hole up close. Good luck with that mission. Let me know how it goes. Now, I'm bringing us back down to Earth, but not for long. If you're ready to blast off for another video, then I have the perfect mission for you. 25 mind-blowing facts about life, space, and everything in between is waiting right here. Or rather, the truth is out there. Don't forget to like, share, comment, subscribe, do all that fun stuff, ring that notification bell, and I'll see you soon for another list. Many boffins died on the Star Wars joke.